Hey, it's Professor Forsyth here. I'm glad you're watching the review for Test 1. I just wanted to let you know that the numbering for these problems are going to be all weird. And what I ended up doing was recording some new problems and inserting old review problems to make one video for you guys with a lot of good content. So it may feel like I jumped from number 12 to number 21 and then I'm back to number 13. Don't worry about the numbers of the problems. Just focus on the topics. The first half is going to be on chapter 1 and then the second half is on chapter 2. And then I even have like a little text box telling you that, okay, now we're on chapter 2 topics. Sorry, the lighting is weird. But yeah, so I just want to let you know that if you have any questions as you go over the review, please feel free to reach out to me. But this is a great way to focus on the topics that you can expect on your first test, which is due this Friday. It is available in the testing center now, and the test is going to cover chapters 1 and 2. All right, happy studying! Hi, and welcome to the Test 1 review session. We're going to be covering chapters 1 and 2, which will be on your first test in this course. I'm going to go through some problems that you'll find on your Test 1 review, and then I'm going to go through some problems that you'll find on your Test 1 review. Let's get started. Write the equation of the line. So we have a coordinate plane here. Let's remember that the horizontal axis is the x-axis and the vertical axis is your y-axis. So we're looking at the red line here, and we want to write the equation of this line. So this line is crossing the x-axis, so the equation is going to be x equals, and where is it crossing the x-axis? It's crossing it at negative 8. So this will be x equals negative 8. Just for the sake of practice, I'm going to make up another one. Let's say I have a horizontal line crossing through here. Since this is a horizontal line crossing the y-axis, that would be y equals. And since it's crossing through the y-axis at 1, 2, it would be y equals 2. To graph the equation, y equals 3. So if we want to graph y equals 3, that means that the line is going to cross through 3 on the y-axis. So here is 3 on the y-axis, but we want to graph an equation, so it is a line. So it's going to be a horizontal line crossing at y equals 3. And that's what your equation would look like. Okay? So that means that for every point on this line, y will equal 3. Just so we can practice, what if we have x equals negative 4? Well, x equals negative 4 tells us that we have a line that should cross through negative 4 on the x-axis. So if we go down here to negative 4, x equals negative 4 crosses through here. That's supposed to be a straight line. So remember that x equals will give you vertical lines crossing through the x-axis. Y equals will give you horizontal lines crossing through the y-axis. Number 3, use the graph to identify the x and y intercepts of the line. So we have a blue line here and it's crossing through the x and y axis. So where your line crosses the x-axis is going to be your x-intercept. So it's crossing the x-axis here at 4, so that would be your x-intercept. And then it's crossing the y-axis here at 2, and that would be your y-intercept. So I'm going to identify them, or I just identified them. Let me write them as points. So the y-intercept is going to be, the x-coordinate is 0, 2. So the point is 0, 2. That's your y-intercept. The x-intercept is going to be at 4, 0. So the x-coordinate is 4 and the y-coordinate is 0. Number 4, give the slope and the y-intercept of the line represented by y plus 10 equals 2x. So remember that we have a form called slope-intercept form. And it's super helpful because it gives us the slope and the y-intercept of any linear equation. And that slope-intercept form is y equals mx plus b. So m, the coefficient for the x term, is going to be the slope of that line, and b, that constant, is going to be the y-intercept of the line. So I want to rewrite the equation y plus 10 equals 2x into slope-intercept form. So I need to get y by itself. So right now I have this plus 10 on the left side of the equal sign. I want to move that, so let me subtract 10 from both sides. And when I do that, I'll have y, 10 minus 10 cancels out, equals 2x minus 10. And if you look, it is now in slope-intercept form. So the m in this equation is 2, and the y-intercept in this equation is negative 10. So that means that the slope equals 2, and the y-intercept as b would be negative 10. Now, you may need to write the y-intercept as an ordered pair because that's technically a point on the line. So that means as an ordered pair, it would be 0, comma, negative 10. So we have the y-intercept and the slope. For number 5, you're given two lines with, for number 5, you have two lines and you're given 2 points that are on each line. And it's asking you to find the slope of each line and then to tell whether they are parallel, perpendicular, or neither. So to get the slope of any line, the formula is y2 minus y1 divided by x2 minus x1. You basically want to subtract your y values in the numerator, and then you divide it by subtracting the x values in the denominator. So let's label these points. So this will be point number 1. We'll call that x1, y1. This will be x2, y2. So let's do the first slope. So we'll say 53 minus 49 divided by 12 minus 11. So in the numerator, 53 minus 49 equals 4. 12 minus 1 is 1. And 4 divided by 1 equals 4. So the slope of line 1 is 4. So let's look at the slope of line 2. So we'll say negative 51 minus negative 75 divided by 10 minus 14. So negative 51 minus negative 75 is positive 24 over 10 minus 14 is negative 4. And then 24 divided by negative 4 will give us negative 6. So we have one slope of equaling 4 and the other slope equals negative 6. So parallel lines have the same or equal slopes. Perpendicular lines are opposite reciprocals, which basically means they would be flipped and opposite signs. And then neither means it's neither one of these. So in this case we have 4 and negative 6. So the answer here would be neither. These lines are neither parallel nor are they perpendicular. Number 6, find the equation of the line having a slope of 4 and a point 1043. Write the answer in slope-intercept form. So it's helpful to use point-slope form in problems like this. So point-slope form is great because if you have the point, a point, and the slope, you can use that information to come up with the equation of the line. So the point is the x1 and y1 in the form, and then the slope is your m. So for this problem, the slope that we're going to plug in, m, is going to equal 4. and then the point that's given is 1043. So that means that x1 will equal 10 and y1 will equal 43. Okay? Alright, so let's plug in this information. So we have y minus y1, which is 43, equals m, which is 4, times x minus x1, which is 10. And now we want to write the final answer into slope-intercept form. So we're going to start by distributing this 4. So 4 times x is 4x. 4 times negative 10 is negative 40. Let's bring down the y minus 43 equals. And then now I already have my 4x, my x term on the right-hand side of the equal sign. But I want to move this negative 43. Let's add 43 to both sides. Then on the left I have y, negative 43 plus 43 cancels out, equals, bring down that 4x, and then negative 40 plus 43 is positive 3. So the equation of the line with the slope of 4 passing through the point 1043 is going to be y equals 4x plus 3. Number 7, find the equation of the line passing through the points -1, 8 and 6, 7. And then write your answer in slope-intercept form. And then if you have any answers that are not whole numbers, write your integers as reduced fractions. So let's again use point-slope form. Y minus y1 equals m times x minus x1. And we do have 2 points to choose from, but we don't have a slope. So we're going to have to first start by finding the slope of this line. And so to do that, we're going to do y2 minus y1 divided by x2 minus x1. So let's label these points. So x1, y1, x2, y2. So we'll have 7 minus 8 divided by 6 minus negative 1. So 7 minus 8 is negative 1 divided by 6 minus negative 1 is 7. So that means that negative 1 over 7 is the slope of the line. And then we have one of our points. We're going to use this first point. And then we're going to use the slope that we're given and plug them into our point slope form. So we have y minus y1, which is 8, equals m negative 1 over 7 times x minus x1, which is negative 1. Now keep in mind, I could have used 6, 7 as my point if I wanted to. It doesn't matter which point you use. Either one will work. Okay, so we're going to, before we distribute, let's take care of this minus a negative. That's going to become x plus 1. So I have y minus 8 equals negative 1 over 7 times x plus 1. So now I want to distribute that negative 1 over 7. So I have negative 1 over 7x. And then negative 1 over 7 times 1 is negative 1 over 7. So y minus 8 equals negative 1 over 7x minus 1 over 7. And then to put it in slope-intercept form, I'm going to add that 8 to both sides. So now I have y equals negative 1/7 x. And then I have minus 1 over 7 plus 8. Well, let's get common denominators so we can add negative 1 over 7 plus 8. Let's get a common denominator of 7. So I have negative 1/7 plus 8 times 7 is 56. 56 over 7. And so negative 1 plus 56 is going to be 55. So my final answer is y equals negative 1 over 7x plus 55 over 7. And remember, it said to write your answer as reduced fractions. and 55 divided by 7 cannot be reduced further. So we are done.
So the way that we can use the graphing calculator to reduce a fraction is like this. So of course, to turn it on. So let's reduce, or let's check to see if 55 over 7 is a reduced fraction. So we will type in 55 divided by 7 and press enter. So we have the decimal value. That's not what we want. We want to get the reduced fraction. So if I press math, I want to choose the first option. It converts whatever you have on the screen, or the last thing that's on the screen, into a fraction. So if you press enter, then it will then give you the reduced fraction. Let me put one that's not reduced, which I'll show you what I mean. Let's say we want to say 10 over 8. Is that a reduced fraction? And you could actually go straight to math here and choose fraction, press enter, and it will give you that reduced fraction. Or if you did the first way, 10 divided by 8, 10 over 8, enter, we get 1.25, but I want to change that to its reduced fraction. So I'm going to press math, enter, and then there it is. So that's the way that you can always double check to see if a fraction is reduced all the way. Number 8, find the equation of the line containing the point 3, 2 and parallel to y equals 2x minus 4. So we're going to write the answer in slope-intercept form. So we need to identify the slope that we're going to use in this equation. And since it's parallel to the given equation, then we're going to use the same slope. So parallel lines have same or equal slopes. So the slope we're going to use is going to be 2. That's your slope. And then we're given a point. The point is 3, 4. So that'll be our x1 and y1. So now we'll use point slope form. Y minus y1 equals m times x minus x1. And then plug in the slope for m. And then x1 and y1 in these spots here. And then we'll go for it. So we have y minus 4 equals 2 times x minus 3. Next, we're going to distribute the 2 on the right. So we have 2x. 2 times negative 3 is negative 6. And then we'll bring down that y minus 4 equals. And then I want to put it in slope-intercept form. So I want to add this, we'll move the negative 4 by adding 4 to both sides. And then we'll have y, negative 4 plus 4 cancels out, equals 2x, and then negative 6 plus 4 is negative 2. So the equation will be y equals 2x minus 2. Number 9, find an equation of the line passing through the point 6, negative 8 and perpendicular to negative 6x plus 3y equals negative 12. So an equation, so two equations that are perpendicular, or two lines that are perpendicular, have opposite reciprocal slopes. So what we need to do is find the slope of the given equation. So let's put this equation into slope-intercept form. So to start, I'm going to add 6x to both sides. So I have 3y equals positive 6x minus 12. And then I'm going to divide by 3 because I want it to be in slope-intercept form so I can identify the slope. So I have y equals 6 divided by 3 is 2, x, negative 12 divided by 3 is minus 4. So the slope of this line is 2. So the slope that we need that's perpendicular is going to be negative 1 over 2 because they're opposite reciprocals of this slope here. Now we already have a point that's given to us, so we have the slope, we have a point. So let's remember point slope form. y minus y1 equals m times x minus x1. Let's plug in our slope and then our point. So we have y minus -8 equals -1/2 times x minus 6. We'll distribute that -1/2, so we have -1/2 x, then -1/2 times -6 is positive 6/2, which would be 3. So on the left hand side I have y minus a negative becomes plus 8 equals -1/2 x plus 3. And then to put this in slope-intercept form, I'm going to subtract 8 from both sides. And so now my final answer will be y equals -1/2 x, and then 3 minus 8 is -5. So that will be the answer to the problem. It's perpendicular to this given equation, and then it goes to the point 6, -8. Next, we're going to find the domain and range of the relation. So the domain of a relation refers to the x values in the set, and the range of the relation refers to the y values in the set. So the x values, you've got 1, 10, 1 again, 19, and 22. So all you need to do is list the values, and you don't need to repeat any. So we'll list them in ascending order. So we'll put 1 first, next we'll do 10. We already have 1 in our set, so then the next one will be 19, and then 22. So that's in our set of numbers here. They're inside those curly brackets. And then for the range, it's all of our y values. So we have 4, 7, 12, 16, and 21. So we'll just list those numbers, and there you have it. So this problem, we're going to find the domain and range of this relation based on the graph. So remember, the domain refers to your x values, and the range refers to your y values. Okay? Let's focus on the domain. So the domain, we're always thinking left to right, smallest to largest. So the very left of our graph starts right here at x equals -3. And at x equals -3, we have a closed circle. So the domain is going to start at -3, and because it's a closed circle, we do include -3, so it's going to be a bracket. And then our graph goes all the way to x equals +3, but we have an open circle, so we're not including 3. So 3 is our limit, but we're not actually going to touch 3, so we're going to use parentheses. So that's how we write our domain in interval notation. Now for the range, it's all of our y values. And so since we're going smallest to largest, we start from the bottom and go up. So the very bottom y value is at x equals -3. And there's a closed circle, so we are including that value. So we're going to start, did I say -3? I'm at -5. So we're going to start at -5. We're going to use a bracket because it does include -5. And then it goes all the way up to here, where the y value of your graph does touch at y equals 4. And now we do have a point here at y equals 4, so we're going to use a bracket for that. So this will be your domain and then your range for this relation. So always remember, think domain left to right, range bottom to top. And for both of them, you're always thinking smallest to largest when you write out your interval. And that's for any interval notation. You always go from smallest to largest.
So 16, find the domain and range of this relation. Write the answer in interval notation. Okay, so like I said before, the domain is your possible x values. Why does that look like that? I'll write it down here.
and then your range is your possible y values. So for domain, let's look from left to right. So going from left to right, and it's almost like, let's see, yeah. So if we go left to right, this graph starts at 1, right? And then it has a dot over 1, so we're going to use a bracket. And your graph starts at 1. We're talking about our x values. And the x values, the graph covers all the way to 3 on the x-axis. So the interval for your domain would be 1 all the way to 3. Now, we're not going to include 3 because it's an open circle. So we're going to use parentheses. So this is the interval describing the domain of this relation. Okay? And you always think left to right, smallest to largest. Now let's look at the range. So bottom to top. Okay, so starting from the bottom, it starts at -5. So this is where your range starts, but it's an open circle, so we're going to use parentheses, and then it goes all the way up to 4. The graph ends at 4 on the y, but it does touch 4, so we're going to use a bracket. Oh, hold on. We are going to use a bracket, and that describes the range. So I'm going to take a pause. I'm still here, but I want to see if you have any questions, because I think this is probably the more difficult concept. So I want to make sure we're okay with this one. Just tell me yes or no. Okay, so one more time. So your domain is referring to your x values. So left to right. So the blue is what we're looking at. So for your domain, think about, and here we'll do, let me do another one of these. 17. Let's practice it one more time. Find the domain and range. So these graphs in MAT1033C look weird for some reason. That's why we have that extra kind of note here. So assume there is an arrow if the relation exits the graph. So what that means is that think of that as an arrow. And then also assume that the endpoint is an integer. That basically means that the endpoint is right there at 2, -4. Okay. So domain. So we're thinking left to right. So if we travel along the left, it's starting at what x value? Right here at 2. So it's going to go from 2 all the way to infinity, because it's an arrow. It's going on and on to the right like that. So we're going to use a bracket by 2 because it's a closed circle. It's an endpoint, and it is an integer. And then we always use parentheses by infinity. So that's your domain. Now let's talk range. So we're going to start from the bottom for range. So from the bottom, it starts at -4. And we're going to use a bracket because it does have an endpoint there. And it's going up. So the arrow is going all the way to the right and then all the way up. So that's going up to infinity with parentheses. 18. Find the domain and range of this relation. So, and this one's also telling you assume that there's arrows on both ends. Okay, so for the domain, remember it's all of your x values, think left, right. So from the left, so our arrows are going out to the graph to the left, and they're going out to the right. So that means that it has all the possible x values in the real number system. That's going to be all real numbers, or a negative infinity to positive. That's your domain. Now the range is your possible y values. Starting from the bottom, So it's an arrow from negative infinity. And it's going all the way up to positive 1 on the y-axis. And then it doesn't include 1, so we're going to use a bracket. If it was an open circle here, then you would use parentheses. All right? Okay. Another domain. So I had a few examples of these because I know these are kind of harder to understand. Find the domain and range. So again, we're going to assume arrows. For whatever reason, IMAT doesn't like to put arrows, so I had to put that little note there for you. So for the domain, this is another one where you have all real numbers. It's going from negative to positive infinity. Because from the left, the arrow is going to keep going. So basically it means it keeps going on and on and on and on, and keeps going on and on that way. And then for the range, you always start from the bottom. So as you can see here, it's starting from the very, very bottom to negative infinity. And it's going all the way up to what y value? Positive 1. And it does touch at 1, so we're going to use a bracket. Okay? All right. So 20, determine if the relation is a function. So for this problem, we're going to kind of list the domain and list the range. Short answer is if any of your x values repeat in your set like this, then you know it's not a function. Let's just list out our values. So we have 12, negative 16, 11, negative 15, and then 11 again. And then for the range, we have 5, negative 12, 3, 6, and negative 4. So let's draw a mapping. So 12 maps to 5, negative 16 maps to negative 12, 11 maps to 3, negative 15 maps to 6, and then 11 maps to negative 4. So we cannot have one input or one value in the domain produce two different outputs. So because we see this here, 11 is repeating in the domain, this means it is not a function. And the whole idea of a function basically means that it's like something where if you input a value, it will produce one output. Okay? Now, different inputs could yield the same output. That's okay. But one input, one domain cannot yield or produce two different outputs. So basically, if you see a domain or input or x value repeating, then it's not a function. All right? Now we're going to look at it on a graph. Select all the following graphs that represent the graph of functions. So what that looks like graphically is that if you do what's called the vertical line test, there should never be anywhere on your graph where it crosses a vertical line more than once at the same time. So like if I were to, and I'm going to just draw a nice fat line. This is our vertical line. There's nowhere when I cross this graph, this parabola, that it crosses this vertical line twice at one time. So this graph, sorry guys, this graph here is a yes. That's a function. Okay, let's look at the next one. All right, that's like a sine or cosine function. So no matter where I am along the graph, it's not crossing it more than once. So this one would also be a yes. Okay, the next one, the graph is here. It never crosses that vertical line more than once. So this is a function. Let's look at the next one. Now this one is not passing the vertical line test. Look here. On that vertical line, 1, 2, 3 different times. This would not be a function. Okay? because it is not passing the vertical line test. Let's do this one. That is passing the vertical line test, not crossing that graph more than once. And then the last one, this circle, is definitely going to fail the vertical line test. On that vertical line, it crosses that graph twice, so this would not be a function. Okay? And what it is saying this input of, say, -1 is yielding two different outputs. It's giving you this x of -1 is giving you a y of 0 and a y of 2. That doesn't create a function. It's a relation, but not a function. Okay? All right. The function f of x equals x squared minus 6x plus 3. Find f of -2. This is basically having you to practice interval notation. So we're going to, all this means is that we are going to plug in -2 everywhere we see x. So that's going to be -2 squared minus 6 times -2 plus 3. So everywhere we see x, we're plugging in -2. And then we're going to follow our order of operations. So we're going to use, do exponents next because there's nothing to do within the parentheses. So -2 squared is -2 times -2, which is +4. Let's bring down everything else. Next, we're going to do our multiplication. So we have -6 times -2 is +12. So we have 4 plus 12, it's positive, plus 3. And then now we have addition, so we can just add left to right. So 4 plus 12 is 16 plus 3 equals 19. So f of -2 equals 19. Okay? Using the graph of the function f of x, find f of 1. What this is basically saying is that when x equals 1, find y. Because f of x, I don't know why it does that there. F of x is the same thing as y. So that's what this statement is basically saying. When x equals 1, find y. So let's look at when x equals 1. Here's the x-axis. This is when x equals 1. Okay, my graph. Okay, my line is real suspect, but we're going to just try to draw a straight line. So when x equals 1, my graph is right, oh goodness, where'd it go? My graph crosses right here, and the y value is 3. So f of 1 equals 3. So when x equals 1, my y value is 3. And my graph, this shape here, crosses at x equals 1 in only one spot right here. So that's why that answer is just 3. Okay? All right, so now find the domain of the function. So we have a couple examples of this. So algebraically, to identify the domain, you got two scenarios you want to look out for. One scenario is if you have a denominator with a variable in the denominator. We never want the denominator to equal 0. So if there's ever a chance that the denominator can equal 0, we want to exclude those values from the domain. Then the other scenario is if you have a square root. You never want there to be a negative number under a square root, because that would give you an imaginary number, and we're not talking about imaginary numbers right now. So you want to exclude any values that would make the radicand, the number under the radical sign, negative, a square root a negative. If you don't have either of those situations, then it's all real numbers. So like here, f of x equals negative 6x squared plus 2x plus 8. So you don't have a square root, and you don't have a denominator or fraction bar with a variable in the bottom. So the domain here would just be all real numbers. If we want to write in interval notation, we would say negative to positive infinity. And that's it. Now let's look at another scenario. Now, find the domain of this function. H of x equals 46x over negative x minus 12. So we have a red flag here. We have a denominator and it has a variable. So that means there could be a way the denominator can be a 0, and we don't want to include that in the domain, because if we have 0 in the denominator, that gives us a undefined answer. So what you want to do is you want to set that denominator equal to 0, figure out when that would happen, and exclude those values, remove those values from the domain. So if we make this equal to 0, what would x have to be to make negative 6x minus 12 equals 0? Let's solve it. So we would add 12. So we'd have negative 6x equals 12 divided by negative 6. So x equals 12 divided by negative 6 is negative 2. So for the domain for this function, so if we think about it on a number line, if we didn't see what's in the red that I circled, it would be all real numbers. Everything here would be the domain. But that's not true, because we want to exclude negative 2. So we don't want to include negative 2 there for our domain. So everything except for negative 2 is the domain. Because if we include negative 2, what happens to the denominator? It equals 0. So this is the graph of our domain. And let's write it in interval notation. So we have two intervals here. We have this interval and then this interval. So the first interval starts at negative infinity and it goes all the way to negative 2. But we're going to use parentheses because we're not including negative 2. And then we're going to do the union symbol. And then the next interval starts at negative 2 with parentheses and it goes all the way to infinity. So this would be your domain in interval notation. So you have to find out what value to exclude from your domain so you can figure out what the domain would be. Okay, then the other scenario is if we have a square root. So you don't want a negative value under a square root. That's going to give you an undefined answer. So to get the domain of this type of function, let's take what's under the square root and let's set it greater than or equal to 0, because this would be okay. This would be okay. So if we solve that, that will actually give us the domain. So we will solve for x by adding the 8 because we want to get x by itself. So we want to get that term with x by itself. So we have negative 2x is greater than or equal to 0 plus 8, which is 8. And then we're going to divide by negative 2. And if you divide or multiply across the inequality by a negative, we have to flip that inequality sign. So we have x is less than or equal to 8 divided by negative 2, which is negative 4. So that's the domain in set builder notation. Let's do that in interval notation. So we have negative 4. All the values less than negative 4 are to the left. And then we are including negative 4, so we'll use a closed circle, but let's also use a bracket. Because we're in intermediate algebra, we're using brackets and parentheses. So that's how the graph would look. Let's write that interval. So we're going to start with negative infinity. Always use parentheses for infinity. And it goes all the way to negative 4. And we're going to include negative 4 because it's less than or equal to. So this would be the domain of this function f of x.
Let's start looking at the concepts in Chapter 2, which focuses on systems of equations and inequalities. So first, let's look at how we would determine if an ordered pair is a solution to a system. So in order to determine if it's a solution, you plug the ordered pair into each equation in the system, and it must be a true statement for each equation. So we will plug in -2 in for x, and then -1 in for y. So we'll have the first one, 3 times -2 plus 2 times -1 equals -8. So 3 times -2 is -6. 2 times -1 is -2 equals -8. And -6 minus 2 is -8. So that checks for the first one. Now let's check the second one. So we have y, which in this case is -1, equals 2 times x, which is -2, minus 18. So -1 equals 2 times -2 is -4 minus 18. And -4 minus 18 is -22. So that does not check out. So for this system, for this ordered pair, it is not a solution. Let's check the other ordered pair. So we have x and y. So we'll have 3 times 4 plus 2 times 10 equals -8. 3 times 4 is 12, plus 2 times 10 is 20, equals -8. I have a feeling this probably should have been a minus 2y, but it's okay. So this would be a no, because it'll be 32 equals -8, and that is false. Let's check. So once we find out that the first one's false, there's really no reason to do the other equation because they both have to be true. So both of these are not a solution. But if both of them gave you a true statement, then that ordered pair would be a solution. Solve the system of equations by graphing. So what I'm going to do is show you first by hand, and then I will show you how to do it with the graphing calculator. Let's start with the first equation. So we have y equals -4x plus 1. Remember that these are in slope-intercept form. And then we have the y-intercept here. And we have the slope here. So we're going to plot our y-intercept, which is 1, and then the slope is -4. So we're going to go down 4, 1, 2, 3, 4, right 1, down 4, 1, 2, 3, 4, right 1. And then we're going to draw our line. Let's now graph the second equation. So the y-intercept is 8, and then we're going to go up 3, 1, 2, 3, over 1. We can go down 3, 1, 2, 3, back 1, down 3, back 1. So I bet this is where it's intersecting here, but it's kind of hard to see when you're doing it by hand. So let's do it with the graphing calculator. So we're going to go to y equals. Let's turn it on. Y equals, so we're going to make sure our equations are in slope-intercept form first. Let's put the first equation, -4x plus 1. And then we'll go down to the second one and put 3x plus 8. Okay, now that we're ready to graph our system, we're going to press graph. Okay, so we can see it's intersecting here, but let's get the calculator to tell us exactly what that point is. So we want to calculate. So we're going to choose this option here. So we're going to say second, trace, and then we want to calculate where they intersect. So we want to go down to option number 5. And so now I'm just defining the 2 lines that I want it to find the intersection of. So first curve, press enter. Second curve, press enter. And now it's asking me to guess. I will press enter. And now it tells me what the intersection is. -1, 5, which is what it looked like on my handwritten one, but it was just hard to see. So the solution for this system is where the lines intersect, and in this case it intersects at -1, 5. And you can see that's where it probably is, but my blue line is kind of crooked. So that's your answer there. The next problem we're going to solve by using the elimination method. So in order to solve a system by using the elimination or addition method, we want to make sure we have opposite terms in one of our variables. So sometimes we automatically have that, which in this case we do in the x terms, and sometimes we have to create opposites. So 7x plus -7x will cancel out. That's our goal. So if we add these equations, 7x plus -7x cancels out. -2y plus 7y is 5y. And then -4 plus -21 is -25. And then to solve for y, we'll divide by 5 on both sides to get y by itself. So y equals 25 divided by 5, which is -5. That's half of my solution. Some x term, comma, -5. Let's get the x term. So what we're going to do, we're going to take our y equals -5 and plug it into one of our equations. So I'm just going to choose the first equation. It doesn't matter which equation we use. And we're going to plug in y equals -5 and for y in one of the equations. So I have 7x minus 2 times -5 equals -4. -2 times -5 is positive 10. So I have 7x plus 10 equals -4. I'm going to subtract 10 on both sides. So I have 7x equals -14. And divide by 7 to solve for x. So x equals -14 divided by 7, which is -2. That's my other half of my solution. So the solution to my system is, wait, what was that? -2, -2, comma, -5. So the answer to the system is -2, -5. Next, we're going to solve this system of equations by using the elimination method. So you could use elimination or substitution, but since it's asking for elimination, we're going to use that. So in order to use the elimination method, we want to make sure that our equations are in standard form. Which is ax plus by equals c. So the first equation is already in that form, but we need to get the second equation in that form. So let's subtract 3x. So we have -3x plus y equals -1. Now I'm going to rewrite the second equation. 6x minus 2y equals 2. And now I have my system, and I want to use the elimination method. So I need to decide if I'm going to eliminate x terms or y terms. And it's really up to you. It doesn't matter. So I am going to try to eliminate my y terms. So let's focus on the y. We have y and -2y. Well, if I were to multiply this first equation by +2, multiply everything in that equation by +2, I'll end up with 2 times negative 3x is negative 6x. 2 times y is positive 2y. And 2 times negative 2 is negative 2. Now I have a new system with equivalent equations, and so now I'm going to add the equations to see what I get next. So 6x plus negative 6x cancels to 0. Negative 2y plus 2y cancels to 0. Equals 2 plus negative 2 is 0. So 0 equals 0. Well, that's a true statement, but our variables are gone. So whenever this happens and we get a true statement, that means that we have infinite solutions. And in MAT1033C, they're going to ask you to put something for x and something for y. You would put infinity for x and infinity for y. That's for MAT1033C, and that's the program you use for your work in this class. And then you're done. You don't have to go any further. Because we got a true statement, this is true, 0 does equal 0. Or let's say we were doing this problem, the variables were eliminated, and we ended up with 3 equals 3. Again, that's a true statement. That means we have infinite solutions. And what that looks like on a graph, it's like 2 identical lines. So it looks like one line, but what's really happening is that you have 2 lines that are literally on top of each other because they are the same line. So they are technically intersecting infinitely many times. And that's our answer, infinite solutions. Next, we're going to solve a system of equations with the substitution method. So in order to do the substitution method, you want to take one of your equations and solve for a variable. And sometimes it will already be set up like that for you, which in this case it is. I have y equals 5x. So what I can do is take 5x and plug it into the other equation in for y. So I'll have x plus, instead of y, I'm going to put 5x equals 6. And then solve for the variable that I have, which is x. So combine like terms, x plus 5x is 6x equals 6. Divide by 6. So x equals 6 divided by 6, which is 1. That's half of my solution. But I need the other half by plugging this x equals 1 into one of my equations. And you should have an equation that's already set equal to y, and there it is right here. So I have y equals 5x, but I'm plugging in 1 in for x. So I have y equals 5 times 1, which means that y equals 5. So my solution for the system is 1, 5. That's going to be my answer. For this problem, we're going to graph the system of inequalities, and then we're going to find out what the point of intersection is. And for this problem, it may be a decimal, so don't be thrown off with that. This is a very good one to use a calculator for. So I'm going to pull up my calculator. And I'm going to move it over here. Okay, so in order to use the calculator to graph an equation, remember we want to put it into y equals slope-intercept form. And these are already in that form. So we're going to go to y equals. I'm going to clear out my previous problem. Let's put the first one in there. So I'm not ready for the inequality. Let's just treat these like equations for now. So I have y 2x plus 2. Now, since it's in slope-intercept form, you can just look at the equation to determine how you're going to shade. So y is less than or equal to 2x plus 2. So that means that we are going to be shading this equation down below the line. So you see how I moved it over to this side and it's flashing? I'm going to press enter until I get the option where it's shading below. So that's shading above, this is shading below. Okay? And if you were to graph this on paper, this would be a solid line. Okay? Let's do the next one. So we have y is greater than, so negative 3/4 x. And actually, I'm going to put this in parentheses. So I'm going to insert parentheses. And then I'm going to say that's x. Now again, I need to shade this. So this is y is greater than. Since the y is by itself, I can select the option where it is shading above. And if I were graphing this on paper, this would be a dotted line. Okay, so now let's graph it. So this is a system of inequalities. So we have a whole region that represents the solution. So the solution here is going to be this overlapping part. Any point in this double shaded region is a solution for your inequality. And now we're curious to see what this intersection point is. So remember, we can do that on the calculator. So we'll say second trace to give us that calculate option. We're going to go down to option number 5, and then we're just going to define the two lines. So first curve, second curve, and then press enter to calculate. And then it gives you the intersection. So it is a decimal. In MAT1033C, I believe it says to round to the nearest hundredths. That's 2 decimal places. So x would be negative 0.73. And then y is going to be positive 0.55. Using the graphing calculator. All right. Okay, this problem is going to be a word problem using systems of equations. So we have the admission fee for an amusement park is $1.50 for children and $4 for adults. On a certain day, 341 people entered the park, and the admission fees collected totaled $874. How many children and how many adults were admitted? So it's important to define your variables for problems like this. So let's say that x is going to represent children, and then y is going to represent adults. Because if you don't define that first, when you solve for x or y, if you forget which variable represented what, you're not going to get the right answer. So the first equation, we're going to set up the total number of tickets. So if we had a total number of 341 people, however many children's tickets plus however many adults tickets is going to equal 341. All right. So that's where we got that from. Now the next piece of information is based on the price, the admission fee. So you collected a total number of fees to be 874. So the total is 874. Well, how do we get that? So for every child ticket, it was $1.50. So $1.50 or 1.5 times x, plus for every adult ticket, it was $4. 4 times y equals 874. And so now we can solve this system of equations here. I'm going to use substitution. So I'm going to take the first equation and I'm going to solve for x. So I'm going to say x equals 341 minus y. So I'm going to take this expression for x, 341 minus y, and plug it into x in the other equation. So I have 1.5 times 341 minus y plus 4y equals 874. So remember, I have x equals 341 minus y. I just plug that in here for x in the other equation. Okay? So now you can use your calculator. 1.5 times 341 is going to equal 511.5. 1.5 times negative y is negative 1.5y. And to bring down that plus 4y equals 874. And I'm solving for y, so I'm going to combine these like terms. So we have negative 1.5 plus 4 is going to be positive 2.5y. I still have my 511.5 plus 2.5y equals 874. To solve for y, I'm going to subtract 511.5 from both sides. I'm going to bring down that 2.5y equals 874 minus 511.5 equals 362.5. And then to solve for y, I'm going to divide by 2.5. So y equals 362.5 divided by 2.5, which equals 145. So remember, what did y represent? Y represented adults. So if y equals 145, we sold 145 adult tickets. And now to get how many children we sold, let's look at that first equation. So we had x plus y equals 341. Well, if y equals 145, we have x plus 145 equals 341. And then we can solve for x by subtracting 145 from both sides. So 341 minus 145 equals 196. So if that means that we sold 196 children tickets. And then you can always check your answer by plugging in 145 for y and 196 for x, and seeing you can get a true statement in both equations. Okay, in this problem we're going to use a system of equations, and we're also going to use the PERT formula to answer this problem. So let's read it first. So in 1 year, Michael earned $6,300 as a work study in college. He invested part of the money at 9% and the rest at 7%. If he received a total of $493 in interest at the end of the year, how much was invested at 7% and how much was invested at 9%? So we're talking about, in this case, simple interest. So that formula is I equals P R T. P times R times T. So what's happening here is that I represents interest earned. P represents your principal or what you invest. R is the rate, and T is time in years. Okay, so we have two scenarios. We have two accounts. So I have, let's see, so I'm going to say I equals P times R times T. And I'm going to use this to kind of organize my information. Okay, so I've got for the 9% account, the rate is 9%, so that means as a decimal we would say that's 0.09. For the next one, it's 7%, so the rate for that account would be 0.07. This is at the end of 1 year, so the time would be 1 for both of these accounts. And now the question is, how much was invested, which is the principal, at each percent? We don't know. That's going to be our variable. We'll say the amount that you invest in the 9% account, we'll call that X. And the amount that you invest in the 7% account, we'll call Y. All right, and so now we've got, he invested a total of $6,300. So if we make these columns represent totals, we'll put that total amount here, 6,300. So what goes here under I? So remember, P times R times T equals I. So if I take X times 0.09 times 1, that will equal I. So we've got 0.09X. And then here we've got Y times 0.07 times 1, that'll be 0.07Y. And then his total amount that he received from his interest was 493. So that would be your total down here. So now I've got two equations for my system. I have this first equation, 0.09x plus 0.07y equals 493. Then I have the second one, x plus y equals 6,300. So now what I'm going to do is take this system, ignore this, and solve. So I'm going to use, just to make this fun, I'm going to use elimination. So if I want to eliminate, say, my x terms, let's multiply this entire equation by negative 0.09. And I have a calculator, so it's not so bad. So negative 0.09 times x is negative 0.09x. Negative 0.09 times y is negative 0.09y. And then negative 0.09 times 6,300 is going to be negative 567. I'm just going to rewrite this first equation underneath. Positive 0.09x plus, well, this should be a negative. There we go. Plus 0.07y equals 493. Now I've got a nice system I can now add. I'm going to get rid of my x terms. So negative 0.09x plus 0.09x cancels. So I have negative 0.09 plus 0.07. It's going to give me negative 0.02y equals negative 567 plus 493 is negative 74. And then now I'm going to divide both sides by negative 0.02. That's going to give me y equals positive 3,700. Now, that's y. I need to get the x. Let's go back to this equation here. I've got x plus y equals 6,300. Well, why don't I just take this? If y equals 3,700, I have x plus 3,700 equals 6,300. And to solve for x, I will subtract 3,700. So 6,300 minus 3,700 will give me that x equals 2,600. Now, again, these are just numbers. The problem is going to ask you, okay, how much did you invest for each account? This is where it's good to go back to your table, or you need to label it somewhere. So X represented how much he invested at the 9% account. So this would be for 9% here. And then the 3,700, that would be for 7%. So it's really important to label what your variables mean when you solve a system of equation word problem.